Assalamualaikum. I'm Puan Nurhuda binti Muhammad. Continue to lecture for the topic of natural and mechanical ventilation. Introduction to natural ventilation. Ventilating is the process of changing or replacing air in any space to provide high indoor air quality for the purpose to control temperature, replenish oxygen, or remove moisture, odors, smoke, heat, dust, airborne bacteria, and carbon dioxide. Ventilation is used to remove unpleasant smells and excessive moisture, introduce outside air to keep interior building air circulating, and to prevent stagnation of the interior air. Definitions. Ventilation is the process by which clean air, normally outdoor air, is intentionally provided to a space and stale air is removed. This may be accomplished by either natural or mechanical means. Natural ventilation system is the process of supplying and removing air through an indoor space by natural means, which without using mechanical systems. There are two types of natural ventilation occurring in buildings: wind-driven ventilation or wind effect, and stack ventilation or stack effect. Mechanical ventilation is forced ventilation using machine, for example, exhaust fan, air conditioner. It used for applications where natural ventilation is not appropriate. There are two types of natural ventilation: wind effect and stack effect. Natural ventilation occurs in two ways: wind effect and stack effect. The wind effect is divided into three: window and door, wall and roof. Also, the stack effect is divided into three: temperature, size and placement of opening, and height of different opening. Wind effect. Wind-driven ventilation design in buildings provides ventilation to occupants using the least amount of resources. It depends on wind behavior, on the interactions with the building envelope, and on openings or other air exchange devices such as inlets or chimneys. By utilizing the design of the building, such as size, shape, and the height of the building, wind-driven ventilation takes advantage of the natural passage of air without the need for high energy consuming equipment. Wind catchers are able to aid wind-driven ventilation by directing air in and out of buildings. As shown, natural ventilation is the flow of external air to an indoor space as a result of pressure or temperature differences. The top left picture shows no cross ventilation from windows, while the top right picture shows windows from above door to create cross ventilation. Cross ventilation is air enters on one side of the building and leaves on the opposite side. The below left picture shows wind-induced ventilation uses pressures generated on the building by the wind to drive air through openings in the building, which creates natural ventilation flow. The below right picture shows stack effect is created by the difference in the temperature between the air inside and the fresh air outside a building. The warmer indoor air rises up from lower areas and escapes through chimney windows, causing incoming fresh air infiltration through windows. Adjustable louvet maximizes utilization of primary north-south wind. Natural ventilation is a passive strategy using both wind and temperature differences to cool or ventilate space. The benefits from natural ventilation include improved air quality and increased energy efficiency. Adding an active component can enhance the effectiveness of these strategies shown. Cross ventilation section obtain maximum performance when inlet and outlet are placed at diagonal or corner in both plan and section. Stack ventilation obtain maximum performance when inlet and outlet areas are equal and minimum stack height is 11 feet. Cross ventilation plan obtain wind wall size should be more than width of window. Wind pressure. Wind moves from high pressure area to low pressure area. Wind causes a positive or high pressure on the windward side and a negative or low pressure on the leeward side of buildings. To equalize pressure, fresh air will enter any windward opening and be exhausted from any leeward opening. Ventilation through window and door. One of the ways to get the natural ventilation, known as cross ventilation. Cross ventilation is air enters on one side of the building and leaves on the opposite side. Type, size, placement and quantities of windows and doors play important roles. As shown, hybrid ventilation or mixed mode ventilation applied for toilet. Hybrid ventilation relies on natural driving force to provide the desired flow rate. It uses mechanical ventilation when the natural ventilation flow rate is too low. A heat sink is a passive heat exchanger that transfers the heat generated by a surface facing the sun will absorb a lot of radiant heat. Therefore, shading systems have been utilized to reduce the amount of solar radiation entering into a building. Natural ventilation system refers to the flow of external air to an indoor space through opening in the building as a result of pressure or temperature differences. An opening out provided to improve cross ventilation. Mechanical ventilation components such as exhaust fan installed at toilet wall to provide the necessary air movement where mosquito are most generated. A heat sink is a passive heat exchanger that transfers the heat generated by a surface facing the sun will absorb a lot of radiant heat. Therefore, shading systems have been utilized to reduce the amount of solar radiation entering into the building. As shown, natural ventilation only works when natural forces are available, for example winds. Wind-driven ventilation arises from the different pressures created by wind around a building and openings being formed on the perimeter which then permit flow through the building. The stack effect is divided into three: temperature, size and placement of opening, and height of different opening. Temperature. Stack effect is created by the difference in temperature between the air inside and the air outside a building. The warmer, less dense air inside is displaced by the cooler, dense air from outside. If there is an opening high in the building and another low in the building, a natural stack effect will be caused. The warmer indoor air rises up from lower living areas and escapes through the upper openings of the building, causing cold air infiltration through windows or other lower openings. As shown, air movement caused by stack effect. This effect occurs when there are air temperature differences within, outside and inside. Warm air in the building will rise up and will be replaced with cold air from outside. Size and placement of opening. Maximize air-induced ventilation by seating the ridge of a building perpendicular to the winds. The proper size and placement of openings with an unobstructed airflow path through the building must be provided. For examples, for open flash situation, it is better to place the stack near the center of the roof, so this effect can be exploited to generate sufficient air movement for comfort cooling method. As shown, wind moves from high pressure area to low pressure area. Cross ventilation is air enters on one side of the building and leaves on the opposite side. Therefore, opening out must be provided to improve cross ventilation. Height of different opening. The higher the column or stack of warm air, the greater will be the mechanism of the air movement inside the building. If the air in the building is warmer than the outside, This warmer air will float out the top opening, being replaced with cooler air from outside. Mechanical ventilation defined as forced air or ventilation by mechanical means. It employs an electrical driven fans to provide the necessary air movement. There are three types of mechanical ventilation: natural inlet and mechanical extract or extract system, mechanical inlet and natural extract or supply system, mechanical inlet and extract or balance system. Natural inlet and mechanical extract or extract system is typically fans in roof areas to extract air provided by opening windows and louvers. The fan causes a negative pressure in the building which sucks air in through the windows and other openings. Although a heat recovery unit could be used to recover the energy in the outgoing air, there is no ductwork to re-inject it back into the building. This is the most common type of system, which also called as an exhaust system, and it is used for kitchen, bathroom, and assembly hall. The fan creates negative pressure on its inlet side and causes the air inside the room to move towards the fan. Room air is displaced by fresh air from outside of room. It can be seen from the pictures that extract system works much like individual extract fans, only with a single central fan unit drawing still air from wet areas. The fresh air is drawn into dry rooms through opening windows, which can be humidity controlled. Mechanical inlet and natural extract or supply system. It also called as mechanical inlet and natural outlet. The process of this system involves air is blown into the building using fans and is allowed to exit from windows and other openings. However, no opportunity to recover energy from exhaust air. The picture illustrates the process of this system involves air is blown into the building through a fan convector. Then air leaks out of the building through opening windows and permanent air brakes or louver. Mechanical inlet and mechanical extract or balance system. It is also called as mechanical inlet and outlet. The system to extract and inlet using the mechanical equipment. Supply and extract fans inject and remove air from the building. Easy to include heat recovery. In summer, opening windows can be used to remove the energy requirement of the fans. Easily to include nighttime cooling without compromising surety. The system is the best system among the systems to create the internal environment required. This provides the best possible system of ventilation, but it is also the most expensive, and it is used for many types of buildings, including cinemas, theatres, lecture theatres, offices, and restaurants. A balanced ventilation system usually has two fans and two duct systems. A typical balanced ventilation is designed to supply fresh air to bedrooms and living rooms where occupants spend the most time. It also exhausts air from rooms where moisture and pollutants are most generated, such as kitchen and bathroom. Mechanical ventilation systems circulate fresh air using ducts and fans rather than relying on airflow through opening windows or roof. The pictures illustrate the possible configuration of a ventilation system coupled with a forced air heating system. It is essential with mechanical ventilation system that the air is heated before it is forced into the building. The air be heated in a central plant and ducted to the various rooms, or a unit fan convector may be used. The picture shows the components of mechanical ventilation involved are propeller fans, centrifugal fans, exhaust fan, and ductwork. The picture illustrates air movement caused by stack effect for high-rise buildings. This effect occurs when there are air temperature differences within, outside, and inside. Warm air in the heat accumulation box will rise up through heat core and will be replaced with cool air from outside. Chimneys direct hot air out of the building. Hot air could be used for energy production. For example, vertical axis wind turbines or Stirling engines are mounted on the chimney, while vegetation reduces sunlight heating. Another illustration for air movement caused by stack effect. The picture shows one of the components of mechanical ventilation system is ductwork. Another example of picture for ductwork of mechanical ventilation system. Propeller fans. It has two or more blades fixed at an angle to the hub. The main purpose is for free air openings in walls and windows, usually used in workshops and kitchens. The disadvantage of propeller fans is create low pressure which cannot force air through long ductwork. However, it can move large volume of air and installation cost is low. An example photos of propeller fan. Centrifugal fans. It consists of impeller which revolves inside a casing shaped like a scroll. Impeller blades can be forward or backward curved section. The advantage of centrifugal fans is create high pressure which can force air through long ductwork in both ventilating or air conditioning system. It provides large fan for large building. An example photos of centrifugal fan. Another example photos of centrifugal fan. Axial floor fans. It consists of impeller blades rotating inside a cylindrical casing. Air flows through the fan in a direction parallel to the propeller shaft. It can be installed without a fan base. The fan can be driven directly by a motor mounted in the airstream or by a motor mounted outside the duct. It can move large volume of air. It more preferred than centrifugal fan because ease of installation. An example photos of axial fan. Axial fan. Impellers with blades mounted and rotating on a motor-driven central shaft. It is located in a cylindrical casing to adaptation to ductwork. And aerofoil blades can be used to increase efficiency. It is a high-pressure fan. Ducting is one of the components of mechanical ventilation system. The purpose of ducting is to deliver air to the air conditioner space. Air carriers are required which are called duct. Duct contains dampers, sound dampers, fire dampers, and control dampers. There are three types of ducting: fixed ducting, flexible ducting, and fabric ducting. Fixed ducting is usually regular in shape. The duct is closed with staples and special aluminium. An example photos of fixed ducting. Flexible ducting. They are typically plastic over a metal wire coil to make round and flexible duct. The round ducts provide less resistance to airflow. It should be used whenever possible. An example photos of flexible ducting. Fabric ducting. The fabric ducting is used for air distribution. Textile ducts are not rated for nor should they be used in ceilings or concealed attic space for screening. An example photos of fabric ducting. Advantages of medical ventilation system. Providing positive ventilation at all times irrespective of outside conditions, specified air change, air under fan pressure can be forced through filters, better indoor air quality, more control of proper fresh airflow, and improved comfort. End of slide. To be concluded, in Malaysia, natural ventilation is not that successful due to the hot and high humidity climate. Thus, mechanical ventilation is a must in order to provide comfort for building users. Thank you.